So far this unit, we've assumed that one of our reactants would always be excess or leftover. Now we're going to learn what to do if you're given grams of both of your reactants. So the first thing you have to do is figure out which one is actually your excess and which one's actually your limiting. So I read through the problem like I would normally. I'm going to have 22.4 grams of oxygen. So I like to write what I have in grams above each one. I don't put the grams in the BCA table. BCA tables are for moles. I have 2.5 grams of hydrogen. And it wants me to find the mass of water vapor formed. So it's asking me to figure out this one. It also asked me to calculate the number of moles of excess reactant remaining. I don't know which one of those it is yet. You might be tempted to say, well, I have less hydrogen gas because I only have 2.5 moles of hydrogen. So that's probably going to run out first. But I also know that the molar mass of hydrogen is much smaller than the molar mass of oxygen. So I actually have to calculate this out first. So the first thing, I'll figure out my before part of my BCA table. I do not know instantly how many moles of hydrogen gas or oxygen gas I have to start. I have to figure that out mathematically. I do know I have 0 moles of water to start because I don't ever have any product before the reaction. So I will calculate my moles for hydrogen and oxygen. 2.5 grams of hydrogen. 1 mole of hydrogen has a molar mass of 2.02. So I take 2.5 divided by 2.02. That gives me 1.24 moles of hydrogen gas. Then I do the same conversion for my oxygen. 22.4 grams of oxygen. 1 mole of oxygen gas, O2, has a molar mass of 32 grams. So 22.4 divided by 32 gives me 0.7 moles. Now at this point, I should be able to mentally figure out which one's my limiting reactant without doing a whole lot of calculations. If I do guess wrong, I'll figure it out pretty soon. So I'm going to look at my number of moles and my mole ratio. According to my mole ratio, I need 2 moles of H2 to every 1 mole of O2. So if I look at this, do I have twice as much hydrogen gas as my oxygen gas? So I don't, because 2 times 0.7 would give me 1.4, and I don't have that. So that tells me that hydrogen is my limiting reactant. It's going to run out before my oxygen. So I will assume that that's true, and I will calculate how many grams of hydrogen, or sorry, how many moles of hydrogen gas I will use up. And if it's my limiting reactant, if this is correct and it's my limiting reactant, I will use up 1.24 moles of it, leaving me with 0 moles when I'm done. And then according to my mole ratio, 2 moles of that to 1 moles of that, I can calculate how many moles of the H2 I should use, because if I have 1.24 moles of H2, according to my mole ratio, I need 1 mole, I get 1 mole, I use 1 mole of O2 for every 2 moles of H2. So I take the 1.24, divide it by 2, because I need half of it, and I will use up 0.62 moles of O2. I had 0.7, I'm going to use up 0.62, so that will leave me with 0.08 moles of O2 left. So that was actually the last question, calculate the moles of excess reactant remaining. That's what I will have left when I'm done. Then I go figure out the last part of my question, calculate the moles of, or the mass of water I have. So now we'll have 2 moles of H2 to every 2 moles of H2O. So if I use up 1.24 moles of H2, I will gain that equal amount of moles of H2O. So then at the end, I will have 1.24 moles of H2O. And then the last step, I just have to calculate the grams of that. 1 mole of H2O has a molar mass of 18.02 grams. So I take the 1.24 times 18.02, and that will give me 22.34 grams of H2O formed. I'll do one more example. Make sure you got it. This question says, when sodium hydroxide reacts with sulfuric acid, water, and sodium sulfate are the products, calculate the mass of sodium sulfate produced. So they want to know how many grams of this I have when I'm done. So I'll put in what I have to start with. I have 15.5 grams of sodium hydroxide. So above my NaOH, I will write 15.5 grams. Above my H2SO4, I have 46.7 grams. So figure out my BCA table. My products will be 0 to start. I have to calculate my number of moles of each. So I take the number of grams I have of the sodium hydroxide, convert that to moles. 1 mole of sodium hydroxide has a molar mass of 40 grams. So 15.5 divided by 40 gives me 0.39 moles of that. And then do the same calculation. 46.7 grams of H2SO4. 1 mole of H2SO4 has a molar mass of 98.09. 46.7 divided by 98.09 gives me 0.48 moles of H2SO4. So now I'll try to figure it out mentally, and if I make a mistake, I can start over. I have 2 moles of NaOH to every 1 mole of H2SO4. So I need twice as much NaOH, and I actually have less of that. So that should mean that sodium hydroxide is my limiting reactant, because I don't have, like, I would need almost 1 mole of it, and I don't have that. So if sodium hydroxide is my limiting reactant, I assume I'm going to use up all of that and be left with none. So this is my limiting reactant. I can double check that though. So I take the 0.39 I'm going to use up, divide it by 2 because I need half as much H2SO4. That will use up the 0.195 moles of H2SO4. I had 0.48. I use 0.195, so I actually have 0.285 moles of that left over. So NaOH is my limiting reactant. So now when I calculate the Na2SO4 that I actually need, I want to make sure I use this mole amount, because this is my limiting reactant. So according to my balanced equation, I have 2 moles of NaOH to every 1 mole of that. So I'll need half as much. So that should be the same as this one. So I'm going to gain 0.195 moles of Na2SO4. So I will get 1.95 moles of Na2SO4 when I'm done. Then the last step, it wanted the grams of that. So I convert that to grams. 1 mole of Na2SO4 has a molar mass of 142.05. So I'll put the 0.195 times 142.05 grams, giving me 27.7 grams of Na2SO4 when I'm done.